Hey guys, my name is Trevor Sullivan. I'm a solutions architect with StratusGrid, and welcome back to our video channel. StratusGrid is an AWS Premier Consulting partner, and we're also an independent software vendor, or ISV, and we provide a FinOps management solution for large enterprises and private equity firms to help them optimize spend in the cloud and reduce cloud waste. That solution is called Stratosphere, so if you're interested in seeing a demo of Stratosphere and getting any more information about it, feel free to hit the book a demo link up here in the top right corner of our website over at stratusgrid.com, and we'd love to talk to you. Now, the topic for today's video is going to be how you can set up a solution built on Ollama, which is basically an open source utility that allows you to run a server very similar to OpenAI's ChatGPT, so that you can run large language models on your own hardware rather than having to use managed services like Perplexity or Anthropic's Claude AI or the very popular OpenAI ChatGPT. So Ollama is an open source utility. They have a really nice model registry right over here where you can sort through a bunch of different freely available models here. Llama 3.1 from Meta is one of the most popular models out there, but there's also the Gemma 2 model from Google here, the very popular Mistral model as well as some other models here that allow you to do things like code auto completion and that kind of thing with a large language model. So feel free to check out the website here for Ollama. It's just ollama.com. And then you can go to the models section here and just look through the different models that are available. Now, Ollama itself is pretty much just an API endpoint. If you check out the documentation, it kind of talks about how it's compatible with OpenAI. But what we actually want to do is have some sort of user interface. And this is where OpenWebUI comes into play. So rather than having to write some code to run inference against the Ollama endpoint that's compatible with OpenAI's endpoints, we can actually use this OpenWebUI interface instead. And what this is it's a graphical interface that you can run. It's just a web application, so it can run as a background service, and you just use your web browser to connect to the OpenWebUI. But then what you do is you actually set up OpenWebUI to talk to the Ollama endpoint so that you can run inference against the large language models. So Ollama itself is the API that actually loads the large language models and allows you to run inference against them. But then to provide that user-friendly interface through a web browser, we can actually set up OpenWebUI ourselves. And then this gives you your complete privately hostable version of something like ChatGPT, where you can just self-host the language model and run inference against it. And all of your data is kept safe locally on whatever instance you are running this solution on. So what we're going to be doing is taking a look at how to set up OpenWebUI as well as Ollama to get that complete solution with the UI and the backend API that you can run on your own Amazon EC2 instance. So what we're going to be doing is going into the AWS Management Console here, and we're going to just choose pretty much any region here. Pretty much any region is going to support GPU compatible models, or EC2 instance types, I should say. But what we're looking for in particular are some different EC2 instance types that support GPUs. If you search for AWS EC2 GPU, we can see a bunch of different recommended GPU instances right here. So this is actually the documentation for something known as the Deep Learning AMI, which is just a pre-built virtual machine image for EC2. But this documentation here talks about some of the different instance types that are available that have NVIDIA compatible GPUs that you can run Ollama on. So we don't want to run Ollama on the CPU because inference is pretty slow on the CPU. Rather, we want to have an EC2 instance that has a local NVIDIA GPU attached to it so that we can get the best performance out of the large language model inference. So what I'm going to be using is actually the G series of instance types. So what we're going to do is take a look at the G series. So if we go to EC2 G4DN, I think it is, let's go check out the EC2 G4 instances here. And sure enough, you can see the G4DN instance features an NVIDIA T4 GPU. And if I recall correctly, this has something like 14 gigabytes of VRAM or video RAM that you can use to load language models into it. So the G4DN instance type is a pretty decent instance type to use for this particular purpose here. So what you want to do is basically spin up a G4 EC2 instance type, and then we can just do all of the setup as far as installing the NVIDIA driver, setting up the NVIDIA container toolkit, installing the Docker engine, installing Docker Compose. And then ultimately what we're going to do is run a Docker Compose stack that we are going to build using a simple YAML configuration. And we're going to run the Ollama and OpenWebUI components as separate Docker containers, but the OpenWebUI container is actually going to communicate or talk to the Ollama container to run inference. So what we're going to do for starters is just head over here to the AWS Management Console and head over to the EC2 service. And what we're going to do is just go to instances and then say, I want to launch a new instance here. And I'm just going to call this Trevor-SG-Ollama here, just to give it a useful name. And then I'm just going to use a bare bones Ubuntu server 24.04. So this is the latest production release or LTS release of Ubuntu server. So we're going to go ahead and use that base image for our operating system here. And then for the instance type here, this is where we're going to choose an instance like the G4DN class right here. And then just to provide a little bit of extra memory, I'm going to choose the G4DN 2X large that has 8 virtual CPUs, 32 gigs of regular system memory, and then it also has a single NVIDIA Tesla T4 GPU that's attached to it that we can use to run inference for Ollama. So down here under my key pair, I'm just going to choose a key pair that I already have associated here so that I can SSH into that EC2 instance once it's been provisioned. Under the network settings here, VPC is kind of a separate topic that we're not going to get too deep into here, but I have a VPC with a public subnet. So I have an internet gateway attached to my VPC, and I just have a subnet that has a route table set up so that I can route out to the internet through the internet gateway. So I've already got all that stuff set up, and I'm going to associate an IPv4 that's publicly routable and an IPv6 address that I can access this instance across the internet using. And then I'm also just going to select a security group here. I'll actually choose to create a new one here. We'll call this Trevor-Ollama. And then we're going to give it a description here, like used for Ollama and OpenWebUI. And then under the security group rules down here, I want to make sure I have inbound SSH, and I think that'll be fine for now. So I'm going to open up another port later on so that we can access the OpenWebUI interface through our web browser. But for now, we'll just go ahead and use that. For your storage down here, because we're going to be downloading large language models, you want to make sure that you bump up the storage to something a little bit larger. If you check out the Ollama library over here and take a look at some of the different models that are available here, some of them are pretty large in size. Now we're going to be sticking with the smaller 8 billion parameter model here just because of the amount of video memory that we have available. But if we take a look at the tags here, some of the models, like the 70 billion parameter models down here, can be 30, 40, 50 gigs in size, and even larger than that. Even the floating point 16 version here is 141 gigabytes. That's a pretty large model. I don't think we're going to be running that in the VRAM of our 13 to 14 gigabyte Tesla T4 GPU instance. All right, so what we want to do is to go ahead and get SSH'd into this virtual machine. Let's go ahead and actually finish launching it here really quick. So I'm going to bump up the storage to something like 50 gigabytes just so we have a little extra storage space here. And then once we've got that, I'm going to come down to advanced details here. You don't have to do this, but I'm going to select an IAM instance profile that allows the Simple Systems Manager agent to communicate with the backend APIs so that I can just manage it through the Systems Manager service just in case I need to do that. And then for the shutdown behavior here, I'll just leave it at stop. And I think pretty much everything else can just kind of stay the same here. All right, so let's go ahead and launch this EC2 instance. And then we'll get SSH'd into that instance and make sure we set up all the necessary software we need in order to run Ollama and OpenWebUI. What we'll do is come back to instances here. And as you can see, I set up another one previously here, but we want this one that I just set up called Trevor-SG-Ollama. And we're going to just copy the IPv6 address that's associated with it right here. And then I'm going to open up a new shell here. And we're just going to say SSH Let me just do cd/ here to open up the terminal a little bit more. We're going to say ssh ubuntu at IP address, and then we'll get logged into this server here. So now the first thing I want to do is just do a quick validation check to make sure that I actually have a Tesla T4 GPU attached here. So what I can do is say sudo lshw-C display, and that will enumerate the display devices that are attached to this instance. And sure enough, you can see that I have an NVIDIA Tesla T4 attached right here. So we are good to go, but I do need to make sure that I have the necessary NVIDIA driver installed so that I can communicate with that GPU from various applications. And we're also going to have to install the NVIDIA Container Toolkit so that we can run Docker containers that take advantage of the GPU capacity as well. So we have to install the NVIDIA driver first. We have to install the NVIDIA Container Toolkit as well. Then we'll install the Docker engine, Docker Compose, and all those prerequisites so that we can get this server set up to run our LLMs here. All right, so the first thing we're going to do is just do a typical sudo apt update, and we'll upgrade all of the base packages just to make sure that we get all the base packages up to date on this system here. So once we do a sudo apt update, then we'll do an upgrade command as well. It looks like there's a bunch of packages that need to be updated here. I also like to sometimes install another utility called btop. So I'll do sudo apt upgrade -- yes, and then I'll go ahead and open up another shell here so I can do some other systems management stuff at the same time. And I'll do sudo snap install btop. Btop is just a nice command line utility. It's kind of a graphical terminal UI 2E type of utility that allows me to monitor CPU, memory consumption, disk utilization, and all that kind of stuff from a nice terminal UI. So once we get btop installed here, it looks like it is complaining about looks like I maybe lost connectivity to it there for a second. Let's go ahead and try that again and see if it works. And it looks like we're upgrading our packages with the apt package manager right over here. All right, so now we've got btop installed. So now if we just run btop, and if I hit the minus key a few times on my keyboard, in the top right corner here, you can see what my refresh interval is. So I like to bring that down to typically something like 800 milliseconds, just so I get frequent updating of my system's resource consumption here. All right, so we've got, 32 gigs of RAM, well, 30.9 gigs of RAM. We've got 50 gigs of storage here. We've got 8 CPU cores right here, and that's consistent with what we saw when we spun up the G4DN instance type. So that's pretty normal. As you can see, the CPU is in use a little bit here because we're doing some apt package upgrades. So we can see the D package, Debian package, package manager doing a little bit of work here. So after these packages have been updated, then we're going to go ahead and install the NVIDIA driver for the Ubuntu server here. So let's just let this finish really quick. And then as soon as it's done, we'll install that driver. And we also need to install the NVIDIA Container Toolkit. So let's pull that up. If I just do a Google search here for NVIDIA Container Toolkit, they have some really simple documentation here. It's just like 2 or 3 commands that you have to run right here. So we run this curl command right here, and then we run apt update again, and then we install the Container Toolkit. So we just install it from the NVIDIA repositories here. So that's a pretty simple process to do, but we can actually install the NVIDIA driver directly from the apt repositories without having to first add the NVIDIA apt package repository. So now what we'll do, that we've updated all the base packages, we're going to do a sudo apt-get install NVIDIA, and I just hit tab here a couple times, and I'll say NVIDIA driver, and then hit tab a couple times. And you can see there's several different versions, historical versions of the driver here. So I'm just going to choose the NVIDIA driver 550 server here. We'll say 550-server, and then say -- yes. And then there's also another utility package that I want to install. So I get the NVIDIA SMI utility. So I think that's called NVIDIA Utils, NVIDIA SMI. Let's just do a quick Google search for that. And I just want to find the apt package name for that. It's called like NVIDIA Utils something. So yeah, I think it's NVIDIA Utils -550 probably, that corresponds to the version of the NVIDIA driver that we're installing on this server. And so that'll basically just make sure that we have the ability to monitor the behavior of the GPU as we are utilizing it. And that'll allow us to validate that Ollama is actually using the GPU resources once we start running inference. So this is just finishing up the installation of the NVIDIA driver here. Then we'll install that NVIDIA utils package as well, because I don't think NVIDIA SMI is installed as part of the driver itself. And then after that, we'll install the NVIDIA container toolkit, and that's going to allow us to run Docker containers that actually utilize the GPU. If you don't install the NVIDIA container toolkit and you try to run a container that refers to a GPU device, then you'll actually get an error message saying that it can't find any GPU that's compatible with containerization. So that NVIDIA container toolkit is very essential in order to run any containerized applications that need to access the GPU. And the reason that we're using containers rather than installing the software like Ollama and OpenWebUI directly onto the server is because as new versions of Ollama and new versions of the OpenWebUI come out, we can simply upgrade to those new application versions by replacing the old container version with a newer version of the container image. And that'll allow us to very easily upgrade the application. And we're not installing anything on the server's file system. So that helps keep our server very clean as far as installing various applications goes. So we're just getting some of the base dependencies installed, and then we'll be able to actually run the Ollama and OpenWebUI inside of these containers using not just Docker, but actually Docker Compose that allows us to create this declarative YAML file that defines the two different containers that we want to run, Ollama and OpenWebUI, and then we can go ahead and just deploy that as a singular stack. Okay, so let's let this driver setup finish here. And then meanwhile, while this is installing here, we can also do a search for the NVIDIA utils package. So let's do an apt search NVIDIA util and see if we can find that here. So yeah, it looks like NVIDIA utils 550 is going to be the package name here. So we'll go ahead and install that as soon as the NVIDIA driver is finished here. And again, this is where BTOP is really helpful because I can see that the compiler is kind of going crazy right here. Or actually, I think that might be the linker. But anyways, there's a bunch of stuff happening in the background that's setting up the actual NVIDIA driver here. That's using a lot of CPU power. And it looks like the CPU's died down there. So hopefully it'll be done pretty soon here. All right, so now our NVIDIA driver has finished installing. Took a couple of minutes to finish compiling here, but now what we need to do is to install the NVIDIA utilities. So let's say sudo apt-get install NVIDIA utils 550 -- yes. And then once we've got this package installed, we can run NVIDIA SMI just to see some details about the GPU itself, and that will validate that we can actually communicate with the GPU correctly. So let's do sudo NVIDIA SMI, and we should just see some basic details like the power consumption and the VRAM consumption. It looks like this is actually 16 gigabytes of VRAM here on the T4 Tesla CPU, or GPU rather. And so now that we've confirmed that, the next thing we need to do is to install the NVIDIA Container Toolkit. Otherwise, we will not be able to run containers that access the GPU. So let's head over to the documentation here and just grab the command to install the NVIDIA Container Toolkit. So this command is just going to add the apt repository here for it. And then we're going to run sudo apt-get update. And you can see we are retrieving some package metadata from NVIDIA endpoints right here. And then we are going to install the NVIDIA Container Toolkit package. And then we should be able to run containers that use the NVIDIA Tesla GPU. All right, so now we want to install Docker because we want to be able to run containers. So to do that, we're going to say sudo apt-get install docker.io. And then once Docker is installed, we can just start running containers, and we should be able to run containers that access the GPU. And we're actually going to do that just to make sure that the NVIDIA Container Toolkit is operating as we expect it to. So after the Docker engine has installed here, there is actually a base image we can use. If we do docker run --rm, so that'll delete the container after we exit, and say -it, that'll make it interactive so we can type into it and get responses from it from standard output. And then if we run the Ubuntu image here, but before we do that, we're going to say --GPUs equals all. And of course, I need to do sudo here because my Ubuntu user is not part of the Docker users group. on the Linux system here. We just need to run it with sudo to run it as root. And so now the Ubuntu container image that we launched this container from actually has the NVIDIA SMI utility built in. So if we run NVIDIA-SMI right here, we can actually see and validate that we are able to access the Tesla T4 GPU from inside of a containerized environment here. So now we know that the NVIDIA Container Toolkit is working correctly on this server here, and we can start to continue our process here. Okay, so we've got that installed. The one other thing that we need to install along with Docker is the Docker Compose plugin, because we're actually going to define OpenWebUI and Ollama as a Docker Compose stack. So what we're going to do is just do a quick search here for Docker Compose plugin install, and they have a really simple guide that we can follow for this. And so what we want to do is head over to the Ubuntu docs here to add the apt repository for Docker. So let's exit out of the Docker container that we spun up to test. Now we're back on the root system. And so we're just going to run this script here that'll add the repository. And then we're just going to go ahead and run sudo apt update, which I think it probably already did right there, but let's just run it anyway, just to be safe. And then we're just going to say apt install Docker Compose plugin. And then we should have access to the Docker Compose subcommand under the Docker CLI. Awesome. So now that we've got that set up, let's run Docker Compose. And as you can see, we have access to the compose commands. In particular, we're going to be using the Docker Compose up command to launch the stack. But in order to do that, we actually have to create the stack for starters. So typically what I like to do is just create a directory for container related stuff on a server. I'll say makedir containers and then cd into that. And then we'll do vim docker-compose.yaml. This is a standard file name that the Docker Compose plugin is going to look for. So when we say Docker Compose up --detach to lift the stack up and actually run the Ollama and OpenWebUI containers, the Docker Compose plugin is going to look for this file unless we override it with a specific file name. But in this case, I'm just going to stick with the default file name here. Now we need to define two different services inside of this file here. So we're going to put in the services root level thing. And if you're wondering about how to do this, just search for Docker docs compose file. And this should give you kind of an overview of how the compose file format actually works. It'll talk about how to specify things like environment variables. It'll specify how to expose ports, how to add GPU support, and that kind of thing. We're actually going to be using this here in just a moment because we need that Ollama container to have access to the GPU, right? So what we're going to do is define two different services, and those are going to be the top level elements here under services. So we'll create one for OpenWebUI, and you can use whatever name you want to. I'm just going to call it OpenWebUI. And then we're going to create another one for Ollama. Now for Ollama, we're going to launch it from a pre-built container image. So we don't have to build a container image because the Ollama team has already done this for us. So if we head out to hub.docker.com and take a look at the Ollama repository, let's just do a search for Ollama right here. There's the Ollama repository. It's just been updated a few minutes ago. So what we can do is go to docker.io/Ollama/Ollama, and that is the name of the container image that we're going to be launching here. And there should be a latest tag here. If I just do a quick search for latest, there should be a tag for that. Otherwise, I could just pin it to a specific version. So yeah, I'm going to go ahead and just use that latest tag. So we'll say Ollama/Ollama here. We're going to have to expose a port for Ollama, and Ollama is going to use port 11434, I think. If you just do a search for Ollama Docker, they actually have a blog post here that talks about all the different parameters that you need to set up. And so the port mapping we're going to create is just to expose 11434 to 11434. So let's go ahead and just specify that here. And then for the environment variables here, we need to add one called Ollama host. And we're going to set that to 00000. And so what that's going to do, it's going to allow the Ollama service to listen on any IPv4 address. And so when we run OpenWebUI, we need to tell it to look at the local IP address of the EC2 instance that we're running. And that's where it's going to look for the HTTP endpoint to run inference from OpenWebUI against the Ollama container. Now, there's another thing we need to add here, which is the volume mount. And so Ollama has a mount location under /root/.ollama inside of the container's file system context. And we can just mount that to a local file system directory by saying ./Ollama. So we're just referring to the current directory where the compose file lives. And then we'll say /root/.ollama. So any state files or any models that get downloaded or any other files that get used as part of running this Ollama container are going to get stored under this location on the file system, but that's ultimately going to map to a directory on the actual file system of the EC2 instance for persistence. So if we ever have to bring the stack down and then lift it back up again with new containers, we'll actually be able to preserve that state on the local file system and not have to download new models and re-register for OpenWebUI and all that kind of stuff. Now, the one other thing that we need to do here is to add the GPU support for the Ollama container. So I'm going to come back to this documentation here called GPU support under the Docker Compose documentation. And what we're going to do is just copy this section right here under deploy resources, reservations, devices, and we're just going to grab one NVIDIA GPU. Of course, we only have one in this particular case. So let's go ahead and go back here, paste that in, get rid of that extra white space, and we should be good to go. So now we're basically just telling the Docker Compose file here that we need to mount a NVIDIA GPU to the Ollama container. All right, I think that's pretty much everything here. One other thing I'll add is just restart and say always. So if we ever restart our host for some reason or some other incident happens, we're just always going to tell it to restart that container if it ever gets into a stopped state. So that'll make sure that the Ollama container is always running. Now for OpenWebUI, we have a Docker container image as well. However, OpenWebUI is actually hosted on the GitHub container registry. So if we go to GitHub OpenWebUI, do a search for that. And then there is a packages section right over here somewhere. So packages and then OpenWebUI. And so what we're going to do is refer to the OpenWebUI container image that's hosted on the GitHub container registry rather than the Docker Hub. So what we're going to do is just copy this reference here to ghcr.io/OpenWebUI/OpenWebUI, and that will be the container image that we are launching from here for the OpenWebUI. So let's say image, and then paste in that path. And for our environment variables here, we need to specify an environment variable that points to the Ollama container so that it knows where to look for that. We also need to expose a port here as well. So we'll map port 3000 to 8080 because 8080 is the port that it's listening on internally. And that should be available over under the documentation here for OpenWebUI. Let's look at the Docker run documentation here. So Ollama base URL, we can specify an endpoint to that. There's also going to be a volume mount here. So inside the container, there's going to be a mount point /app/backend/data. That's where OpenWebUI persists data inside of the container. We're just going to map that to a file system location so that we can persist that data from the container onto the local file system. So let's go ahead and do that as well. Let's say volumes. We'll add a new mount here, and we'll just say // so my containers directory under my home directory /OpenWebUI will be the path where we persist data on the actual file system. But then inside of the container, it's going to be /app/backend/data. And then we're also going to add restart always here to this one as well. So let's say restart always. And then for environment variable here, we're going to say Ollama base URLs. I think you can actually leave the S off of that if I recall correctly, but I'll go ahead and just use this one for now. And we'll say HTTP, and then we're going to plug in the IPv4 address of the host for now. There's other ways to accomplish this as well, but for now, I'm just going to plug in the private IPv4 of the host, which is 10.0.6.238, and we'll do 11.434. And that's going to be the port to the Ollama container here, to the web API that it's ultimately running. Okay, so we don't need to mount the GPU to the OpenWebUI container. They do have documentation on how to do that, but I don't really see why you would need to worry about doing that in this particular case. So we've got the port exposed. You can map any external port. They just happen to use 3000 as an example, but you could choose port 31,000 or 31,552, whatever you want to. But the actual service inside the container is listening on port 8080, so just be aware of that. We've got the volume mount, we've got the environment variable set, we don't need to specify a name for the container because Docker Compose will actually generate a name for the container on demand. We've got restart always set, so I think we are pretty much good to go. I guess we could also specify the main tag. So let's go to the image here, and instead of using latest, we'll just say main. All right, so I think that's pretty much everything we need here. We'll go ahead and give this a try. And I am just going to say makedir Ollama, and then we'll say makedir open web UI here as well. And now we can do a Docker compose up dash dash detach. And of course, I need to do sudo with that as well, since my user is not in the correct group. And so what's happening now is it's downloading the container images for OpenWebUI and Ollama. They are somewhat sizable here, but we provisioned like 50 or 60 gigabytes to our disk that's attached to the EC2 instance, so we should have plenty of space for this. Really, the biggest thing that's going to sit on the file system, though, is the actual large language model, which we saw was probably going to be about 5 to 6 gigabytes in size, depending on which tag we end up deciding to use. So let's give this a second to download the container image. After this whole stack is set up, we're going to be able to log into the OpenWebUI interface, and then we can register an account with that, and that'll become our initial admin account. But then the other thing that we actually have to do is actually go into the Ollama container, because the Ollama container image doesn't have any models pre-downloaded into it. So we actually have to get an interactive shell, also known as doing a docker exec command, into that container, and then we can use the Ollama CLI command to actually download or pull container images for different models from the Ollama model registry that we previously saw. So this is going ahead and it's downloaded both container images, and I think it's going ahead and creating those containers now. And then once that's finished, we can go ahead and download one of the models and register for our account. Now, one other thing in AWS in particular that we want to pay attention to is that we want to go to the security group for this EC2 instance. So if I go to the security tab here and look at the security group that I associated here, I want to make sure that I expose access across the internet to port 3000 so that I can access the OpenWebUI interface from my local system here. So one thing you can do is go to api6.ipfi.org, and this will actually show you what your IPv6 address is, or you can just leave the 6 off if you don't have IPv6 available. And so what I'm going to do is just grab some of my prefix here. We'll go to edit inbound rules. We'll go ahead and add a new rule for port 3000, and I will limit it to this /32 prefix that I have here. So anybody that's coming across from this prefix here will have access to the OpenWebUI interface. I'll just name it there so I remember what this port is for, and I'll save those changes. All right, so now I've opened up access to that EC2 instance, to its IPv6 interface, and so I should be able to access it across there. As you can see, both of those containers did start up successfully. So if we just run docker ps with sudo, of course, we should be able to see both of those running. And so now if I go to the IPv6 address of my EC2 instance over here, let's go ahead and grab this instance and then grab the IPv6 address and then surround it in square brackets and then do colon port 3000. Hopefully we'll see OpenWebUI pop up. Sure enough, here it is. So I'll go ahead and click on the sign up link right here, plug in my full name, Trevor Sullivan, trevor.sullivan@stratusgrid.com, and we'll go ahead and just plug in a password and say create account. And then once we create an account here, that's going to be our initial admin user. And just close that pop up with the new features. And over here, we'll be able to select a model from the Ollama service. And so basically, If we come over to our admin panel settings here, go to settings, go down to connections, we should see that we have this Ollama API endpoint. So 10.0.6.238, 11.4.3.4. And so that's basically just kind of looping from the OpenWebUI container back around the host interface to port 11.4.3.4, which should access the Ollama service. And we can actually validate that just by doing curl HTTP localhost colon 11.4.3.4, and you should just get Ollama is running. And if we do it by IP address, which was 10.0.6.238, we also get that as well. So we should be able to, as long as we can do that from the local server here, the OpenWebUI container should also be able to access that endpoint. But at this point, if we create a new chat, we don't have any models to select from right here. And that's because we need to download a model inside of the Ollama container. So what we're going to do is go to the list of tags right here, and we are going to grab one of the tags for a model. I'm not going to try to load the 16 gig floating point 16 model. I'm going to grab the largest quantized version, which is this tag right here. So if I just click on that, I can copy the prefix right here, or that's the model name and tag, and then come back here. And then we need to exec into this container. Do sudo docker ps. This is our Ollama container right here. So this is our container ID. So what I want to do is exec into that container. So I'll say docker exec -it bf5 and then get a bash shell. Of course, I need to do sudo here again. I'm not typically used to having to do that. But now that we have a shell inside of the Ollama container, we can actually run the Ollama CLI tool. And so what we do is we just say Ollama and then pull, and then say pull, and then paste in the tag that we retrieved from the website. So this is going to go ahead and just download the Ollama model, the 8 billion text quantized 8 model here. And if we wanted to, we could download other ones as well. So if I wanted, the 8 billion instruct model here instead, I could choose this one right here and grab this one as well. It's really up to you which models you want to use, but you do want to make sure that they actually fit in the VRAM of the Tesla T4, which again has about just over 15 gigs of available VRAM. So just keep that in mind as you are kind of selecting a model to actually work with. So as soon as this model is done downloading, we should be able to use it from the OpenWebUI interface. Because OpenWebUI can talk to the Ollama API, it's able to see which models are available in the Ollama service. And of course, this model will be. So we're going to let that finish here. It looks like it's slowed down quite a bit for some reason here. But if I exit out, I just want to show you where all this data is actually sitting on the file system. So if I'm in my home directory, remember that I created this containers directory right here. So if I cd into containers, there's my Docker Compose file. I actually prefer this format of listing output. So there's my Docker Compose file, and then I created the Ollama directory and the OpenWebUI directory to contain the state files of all the different data that's getting created as we log into OpenWebUI, create user accounts, change settings, all that kind of stuff. And then for Ollama here, if we do an ls on the Ollama directory, you can see that we've got this models subdirectory. And if we go into the models subdirectory, you can see that we've got blobs and manifests here. And so these are all the different bits of data that are getting downloaded for the actual model file that we are downloading right over here. So I'm not sure why it has slowed down so much here, but we'll just give it a minute to finish. Okay, so now our model has completely finished downloading here. So we've got the 8 billion text model here. So if we come back over to our OpenWebUI interface here, we should be able to see that show up in the list here. Let's go ahead and just refresh the interface here really quick. And now you can see that it's showing up. Now, one option that you do have is when you create a new chat, if you try to plug in a prompt here, it's going to give you an error that says model not selected. So you have to come in here and just select the model that you want to use. But if you come up to your settings right here and then go down to interface, you can actually select a default model that you want to use. So if you just save that setting, anytime that you create a new chat, it'll just automatically select that model for you. So now what we can do is go ahead and give it a prompt and test it out and make sure that it actually gives us some output that we're expecting from it. So I'm just going to do something really simple like generate a Python script that creates 100 text files. And it should get a result pretty quickly here because we should be using the GPU for inference, and we might get some odd output because we're using the text model instead of the instruct model here as well. I have noticed that the text model doesn't generally do very well with generating code samples here, but let's try asking a question like, what are the major financial events of the 2000s, and just see what kind of result we get from that. Looks like we're getting an error here, so I'm not quite sure what's going on there. Let's try something else, like what are some major historical events in France? And it looks like we are getting some errors here. So what we can do is go ahead and just check out our host here. So what I want to do is run sudo NVIDIA SMI for starters. And what this is going to show you is that the Ollama server process right here is actually using about 9.5 gigabytes of VRAM on the Tesla T4 GPU. And as you're running inference, you'll also see that the power utilization of the GPU spikes up as well. Typically, when it's idle, it doesn't really use all that much power, but when it's actually running inference, then you'll actually start to see it utilize a lot more power. But it looks like we are getting some kind of error here, so let me just try to refresh the interface here really quick. Let's create a new chat and say, what are some major historical events in France? And as we can see, we start to get some output here. So I'm guessing that with the other chat that I had there, there's probably just some weird text parsing issue going on. But as you can see, we are getting a nice response right here from this text 8 billion Llama 3.1 model here. So at this point, you are either welcome to continue working with this particular model, or you can come back to the model registry right here and play around with a different model. So instead of using the Llama 3.1 text model, I might go ahead and choose the instruct model here instead. That's typically the one that I use anyway, but I think I just accidentally selected the wrong one. And again, if you wanted to download that model, you would just want to do a Docker PS on your host here that's running in EC2. And again, you want that container ID. So we would say sudo docker exec -it bf5 bash. And now we have Ollama full, and then we'll just paste in this model right here. Now we're going to download the 8 billion instruct model instead of the text model, and then we can just choose those additional models that we download from the OpenWebUI interface. So it makes it really easy. It's a very ChatGPT-like user interface. And if you do run into this download issue, I actually came across an issue report on GitHub here for Ollama that talks about downloads starting off really fast and then ultimately going down to a crawl. So if you just cancel the download and then restart the download again, so you can just do a Control-C to cancel it, hit the up arrow and just rerun the download command, then hopefully it'll download correctly after that. Hopefully they'll get that figured out, but it does look like to be a common problem with Ollama. So just give it a few different attempts and eventually you'll be able to download it. So after this gets downloaded, it extracts it, it validates the hash against the bits that are downloaded to make sure that everything matches up properly. And then we can come back over to our OpenWebUI right here and probably just wait till it finishes. And so we got our shell back. We'll just exit out of that shell to the container, and then we'll come back to OpenWebUI. We'll do a Control-Shift-R to force refresh here. And if we do a new chat, we should now see that we can choose the instruct model. And again, if I want to go over to settings interface, I can choose the instruct model as my default model now. So anytime that I hit new chat, it'll just use the instruct model. And so now I could say generate a Python script that creates 100 text files in the current directory. And hopefully this will give me some kind of useful output. Now, one of the interesting things about OpenWebUI as well is that if it creates a code sample in Python, at least, I think Python's the only supported language here, but you can actually click this little run button up here, and this will actually run the code sample and test out that code sample. Now, I haven't been able to figure out where on the file system files actually are getting created, but it does attempt to run that code And that gives you a nice validation that that code actually does work the way that the model is expecting it to. So feel free to play around with this, but the idea here is that you can set up an EC2 instance in Amazon Web Services. You can install the Ollama software, run it inside of a container to make it really easy, run OpenWebUI, connect those two services together, and you've essentially got your own private version of ChatGPT here with a user interface that looks very, very familiar with the ChatGPT interface that's hosted by OpenAI. So feel free to give this a try. Keep everything local. You own your data when you use this solution rather than sending your data off to a vendor like OpenAI or any of the other major model providers. Thanks so much for watching, and feel free to leave a comment down below with how you've decided to use this solution in your own environment. And please leave a like on this video and subscribe to the channel so that you can get notified about future videos. Until next time, we'll see you in the next video. Take care.